my name is Joe Adunai, and this is my official, unofficial network statics and solutions. Now it's about the 32nd topic, which is about securing local area networks. The terminals and types of the access layer devices and the highlighted area of their defense. So I've talked about this in previous topics, so I'm going to be short right now, that we can, of course, using internet detection, prevention, devices, access controllers to traffic, we can ensure that the traffic will be encrypted, for example, so we can ensure the authenticity, the authentication of it, the integrity, and the confidentiality with the help of the CIA approach. So I believe I don't have to talk here. You can talk about them. Of course, it is important that we have to protect our sensitive data, but I talked about this in previous videos, so please check them. And then this is a quite easy. So this is quite easy bullet point. Of course, the access layer devices are the switches and the host devices. Of course, for the host devices we can use firewalls, and for switches we can use other stuff. The security, oh come on, the security solutions and the other operations of the end devices, that's just what I said in the previous one. It's the sub point of the previous one. The importance of the level 2 security, the different solutions. It is quite important that what I've spoken in the previous one, that for example access controllers are working from layer 3 and 4, and the firewalls and other dedicated stuffs are working after the layer 3. So actually we are talking about the layer 2 security about switches, and if the data has been compromised at the layer 2, so at the switches, then that even though that there is a protection after it, then the other layers can be compromised as well. So that's the importance that the administrators had to come to an idea, or had to develop technology in order to simply avoid layer 2 traffic or layer 2 attacks as well. Now I'm going to show you some layer 2 attacks and the solutions for them, and that will be this topic is about. So just simply attacks. And the first one is that we are talking about switches. So I have spoken this in a previous video, I remember, but I'm going to show you. Of course, how switches are working, I'm not going to tell it, but of course they have an empty MAC table, they will store the MAC address in the MAC table. So this can be an attack, as I said in a previous video or videos, that when it receives a frame, it will update its MAC table or CAM table, and simply what's going to happen, it will save the port, for example 1, and the physical MAC address of the frame. And it's quite easy that if the attacker will spoof the MAC address, so sending frames with different MAC addresses, then the MAC table will be updated, and not updated, but new entries will be added to the MAC table. And by simply sending a lot of frames in a short period of time or really fast, then the MAC or CAM table will run out of resources, and there will be a denial of service. I believe that's all about the MAC or CAM table attack. And of course you can as I said in a previous video, you can protect this with the port security. We can set how many, or we can do a static port security. That means that we can define a one-to-one connection, that which physical MAC address will be accepted on that port. Or I believe we can define that what should happen. For example, the port should be shut down if that's not that port. Or we can define that how much data it can learn on that port dynamically, or something like that. So that's the MAC address the MAC table attack, and I said we can avoid it with the port security. The other approach is the DHCP that I'm going to just simply write here router. Let's say here is a switch, here is a host, an end device. And what's going to happen, this is a legitimate router, so this is a DHCP server, and this is the attacker here. What's going to happen, the attacker will connect to the switch, and of course the user will send out a broadcast frame to all broadcast frame to get an IP address, and the advantage, or what the attacker will do, that the attacker will send back a DHCP offer before the actual server could reply. So in this case there is an approach that the attacker will provide false IP, or false IP address, false gateway, false domain, therefore the user will not be able to use the network. So that's one attack. And the other attack is the DHCP starvation, when the user would like to get IP addresses from the DHCP server until it will run out of IP addresses. Therefore, when a normal, a legitimate user client would like to get a license, would like to lease an IP address, then it will not speak, or it will not be available, so there will be a denial of service. So in order to avoid the DHCP attack, we have to define again ports, and if I remember well, we have to do trusted and untrusted ports maybe, and the trusted ports should only be trusted if that port is going for a DHCP server. Therefore, by default, this should be an untrusted, because by default these ports are untrusted. Therefore, this port that goes to the attacker is untrusted and should not be able to receive that. Of course, and if I remember well, the other is we can limiting that how many DHCP discover message can come, so we can limit that, for example, after 5 it should time out for some time or something like that. So that's the two approaches for this. Okay, so we have covered DHCP. The other one is the auto is the VLAN attacks, because imagine that here is a switch, and right now it's enough, we just need a host, and here is the attacker, that will be this ugly one, and the switch is connecting to a host. And what I've said in previous videos, that we have the port states, and by default or best case we are not using a trunk link with a user or with a host to a switch. So for example, the attacker can either use a switch and then connect to this switch, or simply do a trunk link from the client, from the attacker client to the switch. And as I said, because the DTP is by default enabled, then if the user, the attacker, will here set the link, the port as a trunk, then this link will be the trunk link independently of this port. Therefore, the attacker can immediately reach this switch, therefore the VLAN, and this is quite easy due to the DTP. Of course, it can be avoided by disabling the automatic services like DTP, and if we set the ports to access ports, because if we set to access ports, it will be a non-trunk link. Or we should shut down ports and only set access ports to which should access really something. Okay, we have the double tag approach, the VLAN double tag approach, when we have two switches. These are connected, And what's going to happen is we know that there is a VLAN tag inserted into the frame, for example VLAN 10, and the attacker will simply insert another VLAN tag behind the first, because the switches will not check whether they have more VLAN tags inside in their head or not. So for example, what's going to happen when this frame will be passed from this one, for example, here the switch will add the VLAN 10, and for example here the attacker will add the VLAN 20, the switch will pass it here, and this switch will send out to all ports which has access to VLAN 10 and will rip it off. So then the next switch will realize that, hey, we still have a VLAN 20 tag, so I'm going to send out on all ports which has access to VLAN 20. Therefore, the attacker could immediately reach a VLAN to which he should never belong. Of course, this is a one-way trip. This traffic will only go to its destination. It will never come back because it cannot come back. So this can of course be used again as a denial of service of sending several frames in order to make unfunctionable a switch. Okay, this is one approach. And I believe I have to talk about STP, and that's the last one. So how does it look like? We have the same example that I've used in the previous video. So everything connected together. And here the aim is to the attacker, here is the attacker for example. The attacker will be this guy here. And the aim is that the attacker will connect with its switch to the root bridge ID, because this will be the root bridge. And what's going to happen is it will set its root bridge ID to a smaller one than this actual root bridge ID. So this will be the new root bridge, and what's going to happen that all the traffic going through the root bridge, therefore the attacker immediately gained access to the root bridge, to the all the data, and that's the advantage of this, that the attacker would like to act as an attacker of this. Okay, and how we can avoid this is quite simple. We are going to delete some stuff here. So it's quite easy that by default we have to use something like port security again, because if I remember well, we can do on the root bridge, we can put root block or something, root yeah, it should be root block or something, root guard. We put root guards on the ports of the root bridge. That means that if other root switch is connected like this switch, then on this interface it already either is shut down or it has a root guard, therefore it will not allow other switch to be a root guard. So this is a simple solution. If I remember well, we have to also use port fast on the end user side, and we have to use BPDU guard, because the port fast and the BPDU guard are acting as a pair, and these should be put on the interfaces that are connected to the end devices, although I don't know what they are doing. And also, if I remember well, here in my STP video I said we can have an alternate or blocked port. That means it shows that there will be a loop-free network, and there should be put loop guard here to also make sure that there will be no loop. So basically, let me check, but that's all about the VLAN attacks. Of course, VLAN about the layer 2 attacks. Of course, you can come up with the example that we can spoof IP addresses, but operation of VLAN, trunking protocol, STP, BPDU related. So you can talk about the operation and other stuff because I've spoken about them. Possibility of defense, I've spoken about them. Configurations, solutions, and steps of port security. I didn't know the configurations, I've talked about them in theory. So basically that's all about this topic. You have to draw a lot, and that's all. Again, if I said something wrong, then I don't really care, and don't forget to subscribe.